The flashover damage from a dirty insulator can go far beyond the switchyard. Proper washing on a regular basis makes the system much more dependable. This video program shows the proper equipment, techniques, and safety measures necessary to ensure the washing you do results in a safer, more reliable electrical system. Before you ever start washing, the substation must be surveyed carefully to ensure a safe and effective cleaning session. One of the first things to do is check wind speed and direction. Is it consistent or gusty? Is it too strong to wash safely? Inspect the yard structures. Look for broken or cracked insulators. Also look for equipment that should not be washed energized, as outlined in the wash manual. Other items of concern are vertical and near vertically mounted, highly tapered Ohio brass bushings, typically found in circuit breakers. These should not be washed or subjected to heavy overspray, even if they have an RTV coating, such as Dow Silgard or Midsun CSL. They are subject to flashover if heavily contaminated water from the connection at the top of the bushing runs down and bridges the creepage distance. Capacitor banks, regardless of voltage class, are not to be washed energized. The conductors and fuse clips are such that the impact of a water stream may damage the components or move them, resulting in a flashover. There are other pieces of equipment that should not be washed energized. These are all listed in the wash manual. An important item is the resistive glaze or RG insulator. RG insulators are identified by a distinctive orange band at the base of the insulator. Some older RG insulators may be difficult to identify because the marking may look like a band of rust. In locations where washing the non-RG insulators will result in overspray onto the RG insulators, include the RG insulators in the first wash cycle and subsequent cycles with the rest of the non-RG insulators. Do not skip washing the RG insulators during 1 or 2 washings and then include them in a later wash cycle. Lightning arresters are a special case. They may be washed energized depending on voltage class. Watch for openings or vents and keep the 2 hose streams away from these areas. Speaking of 2 hose streams, you need to identify equipment that requires washing with 2 hose streams. A complete listing can be found in the wash manual. Additionally, are there fuse disconnects, switch blades, semaphores, oil level gauges, or air vents that may get dislodged or damaged during washing? Make note of them all. Now, you need to consider how you're going to position the trucks and other equipment during the washing. There are a number of factors to look at. Since the angle of the water stream is critical to a successful wash, walk through the process, checking space and obstructions to determine where vehicles and the crew should be positioned. Also, check for tripping hazards. People tend to be looking up and moving around while they're washing, and that's a recipe for trouble if there are obstructions on the ground. 3 other related factors need close attention: wind direction and speed, safe approach and working distances, and maximum stream length distances. All influence the position, timing, and sequence of your work. Wind direction determines the sequence in which insulators are washed. In this drawing, you'd start washing here and move this way, the idea being to keep the overspray from falling on unwashed insulators, possibly causing a flashover. Keep in mind that a change in the wind's direction means you may have to change the sequence of your wash. 2 important factors govern where you place people and equipment. Of course, the minimum approach and working distances, as outlined in the Code of Safe Practices, must always be maintained when positioning personnel and equipment. The other consideration is the minimum stream length distance, which is the distance from the tip of the nozzle to the equipment being washed and is dictated by the voltage and water pressure while using water that meets or exceeds minimum resistance levels. The specifics are laid out in this table, which is included in the Insulator Cleaning Manual. In addition, there are also maximum stream length distances that must not be exceeded while conducting an energized wash. String bell insulators may be washed from up to a distance of 50 feet. All other equipment shall not be washed from more than 35 feet away. The most effective cleaning action is achieved when washing at or near the minimum stream length distance. Employee safety is the highest priority when washing substation insulation. Personal protective equipment, or PPE, is required to protect you from the hazards of energized washing. Always wear approved head and eye protection,
including the company's standard FR clothing.
While you're not required to wear rain gear while washing, it's probably a good idea in order to keep dry. Only company-approved rain gear is permissible. For this application, this means Type 2 flame and arc-resistant garments are the only kind to be worn. Washing substation equipment often requires working in an aerial lift. You must follow all applicable regulations, including the use of approved fall protection equipment while doing this work. Water testing to determine resistance is a vital part of washing operations. Each tank of water shall be tested when it's filled, immediately prior to use, if the water heats up, or any other time a question arises about the resistance of the water. For substation work, no water with a resistance of less than 1,000 ohms per inch cubed will be used. Proper washing technique is an absolute necessity to ensure a safe and effective cleaning. Use a systematic approach. A thorough first wash, followed by a complete backwash, is necessary. Otherwise, contaminants may remain which could cause a flashover. Wash lower levels first, and after you've moved up, rewash the lower sections periodically to make sure contaminants aren't building up. Once an insulator or set of insulators is finished, don't move on until any arcing or corona quiets down. It should diminish in a few seconds. If it continues, you'll have to rewash. Several important techniques govern the wash itself. Test data and experience show that the entire surface of the insulator must be washed. In practice, this means cleaning as if the insulator had 4 sides, each 90 degrees offset from the other. Start by firing the wash guns near the insulator without hitting it to allow the guns to come up to pressure. Watch the overspray to make sure it's not hitting anything vulnerable. If 2 hoses are used, they should oppose each other, one to each side, and move up and down together to achieve the most effective wash. Once the 2 streams have made their cleaning passes from the original angle, the nozzle operator should backwash by positioning themselves 90 degrees either direction to complete the coverage. Since insulators are usually arranged in rows and sections, it may make sense to do an initial wash of several insulators while moving down a bus section or breaker, then move to the 90-degree offset to complete the backwash. An unobstructed, twin-stream, 180-degree offset wash and backwash is the most effective way to clean insulators and should be the goal for every wash. Due to obstructions, adjacent equipment, or overspray dangers, it may not always be possible to obtain the desired positions. Every effort should be made to do so. If it's plainly impossible, then wash passes and duration may need to be adjusted to get surfaces as clean as is practical, or the wash should be done de-energized if there's a risk of flashover. Here's the result of a test wash on a dirty insulator using nozzles 90 degrees apart rather than the preferred 180 degree offset. You can easily see how the dirt left behind would cause a flashover. Another important consideration is the angle of the water stream as it impacts the insulator. It should be at an angle between 30 and 60 degrees to the underside of the insulation bells, as shown here. Again, if it's impossible to set up the correct wash angle due to the height of the structures or interference from other equipment, get as close as you can to the correct position and wash as thoroughly as possible. Okay, now that we've got the angles straightened out, let's talk about wash patterns. As we've emphasized all along, the idea is to be methodical and systematic in all phases of the wash. Because of the danger that dirt, rinsed from one part of the insulator, may build up on an unwashed part and cause a flashover, long insulators should be washed in sections, then given an overall rinse. In practice, this means that all insulators 70 kV and below should be washed in one section, all 115 kV insulators in two sections, 230 kV in three, and 500 kV in 5 sections. Vertical strings of insulators, whether mounted at the top or bottom, are all washed the same way. Start at the bottom, wash upwards in sections, re-rinsing the previously washed sections on each pass. Horizontal strings should also be washed in sections, just like the verticals. The difference is the starting position is determined by wind direction. Start washing so that the initial dirt-laden overspray does not land on unwashed insulators. Then wash in sections like verticals. When washing vertical post or cap and pin insulators and bushings, a more defined pattern of washing is necessary. Two common patterns are used. One, called straight, is used by some crews. It is done by starting at the base, moving up, then down, then across, then up and down the other side. This is an effective cleaning method when the initial pass is made at a rate fast enough to wet and remove enough of the contamination to eliminate a flashover. Finish by moving up and down the entire length, sweeping back and forth. Washing an insulator in sections is easily done using the other pattern called the box. As seen here, the wash moves a third of the way up, then over, then down, back to the start, then all the way up to the top of the second section, over, then all the way down, and so on, until all sections have been washed. Again, the initial wash is done at a rate fast enough to wet and remove enough of the contamination to eliminate a flashover. Then a second pass is done, adding a sweeping motion. The sweeping motion, as the wash stream is moved slowly up and down the insulator on the second pass, is very effective at removing surface contamination. Don't forget to backwash all sections after you've done the initial wash and rinse. One way to check the effectiveness of your wash is to listen for the impact sound, sometimes referred to as ringing, and make sure the runoff is clear before you stop. When you're done, conduct a visual inspection, using binoculars if necessary, to make sure all surfaces are clean. Your care and close attention to this process ensures the safety of the crew, the effectiveness of the wash, and the continued reliability of the distribution system. Thanks for watching.